Winter is approaching and we expect better contacts on lower bands like 80 meter and 160 meter. Only downside for propagation on lower bands now is the solar activity. With solar cycle 25 near its peak, or some say there will be two peaks, one now and another in 2026, we cannot expect that good propagation on lower bands. In general, higher bands are better during solar maxima. In winter months, atmospheric noise, mostly due to distant lightning, is likely to be lesser than during summer storms. That is one reason why 80 meter band will be better during winter months. Atmospheric noise is more of a problem in lower bands than higher bands. Here we are considering the natural noise and not the urban noise due to ever so many devices pumping RF into the environment. I still remember my early days in ham radio during 1986 or so, when I had to migrate to 80 meter from 40 meter due to low solar activity. That would have been the end of solar cycle 21 and beginning of solar cycle 22. I was having only a Philips Prestige vacuum tube radio as receiver. So I was limited to 40 and 80 meter bands. The radio did not cover the higher amateur radio bands, though it was a 4-band radio in those days. When 40 meter propagation came down due to low solar activity, I started listening the EC net on 80 meter at 10 pm. Later, I added an 80 meter coil to my VU to VW and QRP VFO and went on 80 meter, not as QRP but as 120 watt TX using my 3x807 homebrew setup. That's a vacuum tube setup. Antenna was on top of tall coconut trees and I could make contacts within my state and to the neighboring state of Tamil Nadu in those days on 80 meter CW and AM. But now I am not even able to hear the morning 80 meter net on 3600 kHz, though the net control station is just a few kilometers away. That is because the noise flow is quite high even with a much better commercial dedicated amateur radio FT710. Maybe it will improve in the next 2 months as I could hear something in November 2024 as shown in the initial video clip. My 80 meter inverted V dipole has feed point at about 5.5 meter and ends at 4 meter because I am not at the same old location and there are no tall trees in the current compound, not even a single tree. Recently, I have elevated the middle of one limb of the 80 meter dipole up to 9 meter as that is the place where I have a fiber mast up on first floor terrace for other antennas. Still, I can hardly hear anything on 80 meter. D layer of the ionosphere can absorb 80 meter signal significantly during daytime. As D layer disappears at night, longer distance intercontinental contacts are feasible on 80 meter. During daytime, 80 meter can achieve mainly local contacts in the range of a few hundred kilometers. At night, the range may extend a few thousand kilometers. Coverage may be better at high latitudes, especially in winter, due to lower ionization by sun rays. As mentioned initially, during summer, Distant lightning can contribute significantly to static noise and poor reception on 80 meter. Higher effective radiated power gives an advantage in overriding background noise. Very high antennas and full legal limit power gives a definite advantage on 80 meter, both of which I do not have. An important challenge in 80 meter operation is to have an antenna with low angle of radiation needed for long distance communication. Usual types of dipoles mounted lower than quarter wavelength of 20 meter will produce high angle of radiation, the so-called cloud burners. They will be useful only for short range communication by near vertical incidence sky wave propagation. A vertical antenna for 80 meter needs to be 20 meter tall, which is difficult to construct. Dimensions can be reduced by adding a loading coil and electrically shortening the antenna. But that will lead to power losses through resistive heating of the coil wire. As the maximum usable frequency MUF is seldom in the range of 3.5 MHz corresponding to the 80 meter band, skywave propagation is not the problem. Rather, it is the high D layer absorption during daytime. So we have to ensure that the DX communication path is mostly through darkness, not involving the daytime part of the globe. There can also be good dark side gray line propagation along the twilight zone. Polar routes away from equatorial thunderstorms is a good option for 80 meter propagation. But these may need directional antennas or antenna arrays rather than simple dipoles. Gray line propagation on 80 meter is supposed to be most effective during the spring and autumn equinoxes. During night at higher latitudes, especially during winter, skip distance may be high, preventing shorter distance communication on 80 meter. Even though winter is better time for 80 meter, during peaks of solar cycle, auroral activity can make the band useless in high latitudes for hours together.